Hello and welcome to this AQA Further Math Statistics video, second in the series looking at continuous random variables and PDFs. And this time we're going to be looking at further functions of continuous random variables. So just to remind you what you should have learnt from the first video in this series, we looked at the expectation of g of x when g of x was a linear function, and this formula here for the expectation of a function of x works whether g is a linear function or not a linear function, which is what we're going to look at in this video. And we also examined the formula for the variance of a function of x, and again this is a formula you need to learn and be familiar with, just as the variance of x is the integral of x squared fx minus e of x all squared, or ex squared minus e of x all squared. The variance of a function of x is simply obtained from this formula, and again you should familiarize yourself with that. So you may need to just stop the video for a moment and read through this example and think how you might approach finding the expected value you've been asked to find here. So first of all, we're talking about the expected value of the area. We'll call that A, and that's going to be our function of L. And we know that the sides have length L and 2L, so the area would be obtained by multiplying together L and 2L. So our function is 2L squared. We want to find the expected value of 2L squared, and that we can very simply do as g of L is 2L squared. So we can simply integrate our function multiplied by the probability density function f of L dl, and we integrate between the limits 0 and 5, and you should be able to just check that that will give you the result 50 over 3 for the expected value of the area for this triangle. Again, you might like to pause and just think yourself how you might find this probability. So we are asked to find the probability that the area, which is 2L squared, is greater than 32, and that implies that L squared must be greater than 16, and that in turn means that L must be greater than 4, because we can't involve negative values because L's a length, so must be greater than 0. And we want the probability that the area is greater than 32, which is the probability that L is greater than 4, and you should recall that that's probability simply obtained by integrating our probability density function between 4 and the upper range 5, and that will give you 1/5. So this demand here now, we're being asked to find the expected value of the volume of a cube, and we're told that the cube has sides of length 2L. So the volume is 2L all cubed, or 8L cubed. So we want to find the expected value of our function here, and that's E8L cubed, and that's probably easier if you recall from our work when we looked at linear functions. If you have a variable multiplied by a constant, that would simply be the same as, so if we find the expected value of L cubed, which is going to be the integral between 0 and 5 of L cubed multiplied by f of L, the probability density function, dl, and that gives us 125 divided by 4. So the expected value of the volume is going to be 8 multiplied by the expected value of L cubed, and that gives us 250 for the expected value of the volume of that cube. And finally, we've been asked to find the value of the variance of the volume of the cube. So this time, variance, our volume is 8L cubed, and in order to simplify that, if you recall, the variance of ax plus b is a squared multiplied by the variance of x, so this would actually be 8 squared multiplied by the variance of L cubed, just to slightly simplify our integrals in terms of having lots of numbers in there. And if we want to find the variance of L cubed, we are going to use the formula at the beginning, where L cubed is our g of L, is our function of L. So it's going to be the integral between 0 and 5 of our function g squared multiplied by f of L, the probability density function, and then we're going to subtract the expected value of L cubed, which is the integral of L cubed multiplied by the probability density function between 0 and 5 squared. And that's written out for you here. So our EL cubed squared minus EL cubed all squared. So we have two fairly straightforward integrals to do there, and you should be able to obtain the answer here for each of these. We had our 125 over 4 earlier anyway, and we need to just obtain this integral, the value of that definite integral, and that then comes to 1255.6. and remember, variances, particularly if we're talking about something cubed here, they're in units squared anyway, so variances can end up being very big, so don't get put off by that. So the variance of the volume, which is the variance of 8L cubed, which is 8 squared or 64, multiplied by the variance of L cubed, is going to be 64 multiplied by 1255.6, and that equals 80358.4. Again, very large, but you can get values of that sort of size when you're looking at volumes and variances. And that concludes this second video in this series.